Hi, this is my presentation for the project, the ending project of this course. Let me start by sharing the screen. All right. So in this project, we have been provided with this data set, uh, which has close to 10,000 rows. And we have five columns: temperature, ambient pressure, relative humidity, exhaust vacuum, and net hourly electrical energy output, PE, in terms of megawatts. Now, the idea is to uh, use these features and try to predict this label, right? So, since the predicted output is an integer value, this problem has been identified as a regression problem, a supervised machine learning case. Now, so yeah, that is the point number one for evaluation for evaluation criteria. So we have identified this approach as a regression. Um, Features to use, since there are only four features, we will use all four of them for this particular model building. And let's talk about possible algorithms. So for regression, we can use various algorithms, and we have chosen here, as you can see, linear regression, ridge regression, lasso regression, random forest, and support vector regressor. Now, the second part of our criteria overview says that did you compare at least two different models, different algorithms, different combination of features, or different hybrid parameter combinations, the validation set or cross validation to optimize your model. Now, what we have done here is we have compared five different models, and for cross validation, we are using grid search cross validation to find the best model with best parameters among all these five models and the different combinations of hyperparameters, and we are using R square as our evaluation metric. Now, after running the grid search cross-validation, we got random forest with the best R square score, which was 0.9618, with the following parameters, which is max depth is 20, max features are given by SQRT method, and N estimators were 200. The second best model was ridge regression with R square value of 0.9282, not as high as random forest, but not but pretty good. And the only parameter we check for ridge is the alpha, and the alpha value of 10 gave the grid search cross validation found out 10 to be the best value, giving the best R square score for this regression. Comparing both of them, we decided to run our evaluation using only random forest regressor because it gave a very high R square output. Now for model evaluation, we are using four different evaluation performance parameters, which are mean absolute error, mean squared error, root mean squared error, and the R square value. So as you can see here, the mean absolute error was 2.2, mean squared error was 9.5, and RMSE was 3.1, with the overall R square score of 0.967. And so this is a pretty good estimator based on the data we have. Now coming to the model interpretation part, did you correctly interpret and clearly communicate the performance of your model? Now, to do that, we used something called as feature importance that is readily available in scikit-learn. And we can see the ambient temperature and vacuum have the highest weightage for predict of this model to predict the PE value. Now, how are they correlated? To check that, we see the dependence plot of AT versus PE, and yeah, you can see there is a clear negative correlation between the PE value and the AT value. As the AT increases, the performance decreases, which is also intuitive. As the temperature rises, the performance will decrease. Now, the slope at every point is not the same. This is not a 100% linear graph, but there is clearly a trend line here. So further analysis we can do using the correlation matrix. So here you can see in the correlation matrix that PE and AT are highly negatively correlated. So as the V and PE are highly negatively correlated. Pressure and humidity are also correlated positively, but not so much. So they have less impact on the final predicted value. With that, I would like to conclude that for the given data set, we were successfully able to compare successfully able to identify the type of machine learning problem, which is a supervised regression problem, because we have historical data and we have to predict a number. Secondly, we compared five different algorithms. We used the grids search CV to find out the best set of best combination of hyperparameters, and we narrowed our from five we narrowed down to two, and from two we picked the best, which was the random forest regressor. On for this random forest regressor, we calculated the performance metrics, and we got a pretty low error and pretty high R square value, very close to one. And finally, we did feature importance and figured out that temperature and vacuum, ambient pressure and exhaust vacuum played most significant role in prediction of our electrical energy output, net hourly electrical energy. With this, I like to thank the instructor, Duke University, and Coursera for providing this knowledge and helping us enabling us with this tool for enhanced data analysis. Thank you.